Question 2, it's asking to describe Fick's law and how it impacts oxygen availability at altitude. Fick's law describes how gases move across a membrane or tissue. It states that diffusion across a sheet of tissue is directly related to the surface area of the tissue, the diffusion constant of the specific gas, and the partial pressure differences on each side of the tissue. It's inversely related to tissue thickness. This means that at higher altitudes, atmospheric pressure decreases, which leads to a lower partial pressure because the pressure gradient is reduced. The oxygen diffusion in the blood also decreases. So an example of this, let's say at sea level, the partial pressure of oxygen in the alveoli, let's say it's equal to about 100 millimeters of mercury. And then the partial pressure of oxygen in the venous blood is equal to about 40 millimeters of mercury. So you would subtract P1 minus P2, so 100 minus 40 is equal to 60 millimeters of mercury. And then at altitude, let's say that PaO2 is equal to about 60 millimeters of mercury, and PvO2 is equal to about 40 millimeters of mercury. So 60 minus 40 is equal to 20 millimeters of mercury. So at sea level, you have a faster diffusion of oxygen than you do at altitude because there's a larger pressure gradient at sea level than there is at altitude.